All right, here is the first lesson for Unit 6. We're going to look at exponents. Just a little review of what exponents are. You have a number. We call that a base. You could have variables or anything, but you have a number. And then you have, it's raised to an exponent. Okay? So you have 6 to the power of 2. The power is your exponent. And then we can evaluate it. 6 to the power of 2 is the same thing as if we were to say 6 to the power of 2, we can expand that as saying 6 multiplied by itself 2 times, which is equal to 36. Okay, that's what it means. So for example, we have here 4 raised to the power of 3. So this is 4 times 4 times 4 equals 64. 4 times 4 times 4, 64. Same thing here, example 2, you have negative 5. Here we use parentheses to hold the negative with the 5. So that's negative 5 squared, which means it's negative 5 times negative 5. Negative times a negative is a positive, and 5 times 5 is 25. Okay, so that's a quick review of what exponents are. But in this lesson, we're going to look at how, well, some laws of exponents, or we can say rules. The first thing you have to know is that anything to the 0th power is equal to 1. So for example, if you have 6 to the 0th power is equal to 1. We can also put that in decimal. 6 to the power is right here. To the power of 0 is equal to 1. And then the other rule is when you have the same base, so you have a to the power of m, and then you have a to the power of n, they have the same base. So what happens here is you just simply add the exponents. Okay, so for example, here you have x to the power of 3, x to the power of 4, since they're the same base and they're being multiplied together. You just bring over the same base, which is x, and then 3 plus 4, okay, 3 plus 4, which is equal to 7. So this will end up being x to the power of 7, okay. If it's being divided and they have the same base, you subtract the exponents. So here you have y to the power of 5 divided by y to the power of 2. So this ends up being y to the power of 5 minus 2. So that equals to y to the power of 5 minus 2 is 3. Okay. And then if you have a power raised to a power, you multiply the exponents. Okay. So you have r to the 3rd power raised to the 5th power. So this would be r to the 3 multiplied by 5. Okay. So this ends up being r to the power of 15. These are just some rules that you have to remember. And then you have the negative power. So when you have something raised to a negative power, the whole thing moves down to the denominator. Or if it's already in the denominator as a negative, it moves to the numerator. So for example, here you have 5 to the power of 2. So for here, you're going to draw a fraction bar, put a 1 on the top, and then this one ends up being 5 to the power of 2. Right? And then here, when you have two base multiplied together and it's raised to an exponent, it basically distributes. So it would be a to the power of m times b to the power of m. So for here, the 3 goes to the 2 and the 5. So you would expand this out by writing 2 to the power of 3 and then y to the power of 3. Okay. Same thing for a quotient. If you have a division, a m, b, m. So this would be x4 over 3 to the power of 4. And then just some words to look out for. Exponential form, it's when you have it all close to get like written in one term. In word form, it's 9 to the power of 5, or 9 to the 5th power. Here's the expanded form, because you have 5 9s, so it's 9 times 9 times 9 times 9. And then standard form, which is basically when you're doing 9 times 9, 9 times 9 times 9 times 9, whoops, which is 59,049. Okay. All right, let's go ahead and practice some of the rules. So the first one is pretty easy. Remember that anything raised to the 0th power is equal to 1. So 3 over 4 to the 0th power is equal to 1. I can, do this a little bit more, like giving you more explanation. This is basically 3 to the 0th power, which is 1, divided by 4 to the 0th power, which is also 1. 1 divided by 1 is 1. This is y to the 0th power is 1. So here, same thing. The most outer part is 0. So basically this ends up being x to the 4 multiplied by 0, okay, which is equal to x to the 0th power, which ends up just being 1. And then even 0 to the 0th power is also equal to 1. Okay, all right. That helps whenever you're trying to simplify things. That comes in handy. All right, for this one, this is where if you have the same base, you add the exponent. Okay. Also, I'll tell you what happens in these 3 situations where you actually have like coefficients out in the front, even number 7. But let's go ahead and do 5 and 6 first. There's more simpler examples. So you have x squared times x cubed. So you just bring over the same power, same base. And then you do 2 plus 3. Okay. And then that ends up simplifying down to x to the power of 5. That's a 5. Here, this would be 3 to the power of 4 plus 5, which is equal to 3 to the power of 9. All right, so here, these next 4 problems, we have to be a little careful because we have 2 things going on. You have 10 as a coefficient to x squared multiplied by 3, which is a coefficient to x to the 4th, and everything is being multiplied. So we're going to kind of collect things together. So what happens here is you have to do 10 multiplied by 3. I'm going to first just write it all out. So this is 10 multiplied by 3. Okay, I'll simplify it in just a second. Times x squared. And then you have your x to the 4th. Okay, so here you would multiply these two. 10 times 3, which is equal to 30. These get multiplied. And then remember the exponents, they get added to each other. Okay, so it's going to be 2 plus 4, which is equal to 6. And that's my final answer. Okay, same thing here. We're going to collect everything that are alike together. So we're going to do negative 6, okay, multiplied by the 4. So those get multiplied together. And then here you have a to the 1st power. So this is times a. I'll go ahead and write the 1 up there. And then a to the 3rd power times a to the 3rd power. And then you have b times b to the 2nd power. And then b to the 6th power. And let's go ahead and multiply. So negative 6 times 4. Negative 6 times 4 is negative 24. So this ends up being equal to negative 24. And then you have a to the power of, and we don't multiply them, right? We add them. 1 plus 3, which is 4. And then b to the power of 2 plus 6, which is 8. All right. 9 times 5, which is 45. And then you have p. Remember there's a 1. So 1 plus 2, which is 3. And then q is 1 plus 4, which is 5. Okay, I kind of skipped this step by writing everything out, I just did the calculation. You can do that as well if you feel comfortable. Or if you want, you can go ahead and write it out as well. So you could, first collect everything together, 9 multiplied by 5, and then P1, P2, Q1, I'm just putting all of them together, and then Q4, and then 9 times 5 is 45, 1 plus 3 is 3, 1 plus 4 is 5. All right, 6 times negative 7, so that's positive 6 times negative 7 is negative 42. And then x is 5 plus 2, which is 7. And then you have y to the power of 8 plus 4, which is 12. And that's that. All right, quotient rule. Quotient rule is when you subtract the exponents if they have the same base. So right here, you have r. You have 9 minus 4. 9, the numerator, subtract the denominator exponent. So you have r. 9 minus 4 is 5. Now, this one, I'll show you what happens here, and then I'll show you maybe an easier way to handle this, okay? So here, let's go ahead and apply the rule. So there's 3 minus 3. So that ends up being m to the power of 3 minus 3 is 0, and anything to the 0th power is equal to 1, okay? Another way you can think about this is, let me rewrite the problem here. Whenever you have the same thing in the numerator, same thing in the denominator, it's basically, you can cancel them out, and that just equals to 1. Anything divided by itself is equal to 1. You can do it that way as well, okay? Number 13. So here we have a lot of things going on. Let's organize everything. So you have here A, 6 minus 2. And then you have B, 4 minus 3. So this ends up being A, 6 minus 2 is 4. And then B, 4 minus 3 is 1. I don't have to write anything, so it's just B. Here, you do have some coefficients, so I do have to first go ahead and divide 6 divided by 2, and then and then you multiply that by x, and then 4 minus 3. So this ends up being 6 divided by 2 is 3, and then you have 4 minus 3, which is 1, and so that's just 3x. Another way you can do this is just by reducing it. So let me start over again with this problem. You can do 6 divided by 2. 2 goes into 6 3 times. 2 goes into 2 1 time. And then here, oh, I forgot an x here. And then you can just do 4 over 4 minus 3, which is x. So this is just 3 times x. All right, so you have negative 36. The negative can go to the numerator. So negative 36 divided by 4. Let me just do that part in the calculator. Negative 36 divided by 4. So the number part just becomes negative 9. And then negative 9. And then you see when you have the same thing, we can just cancel it out. We can just have C2 divided by C2, that's just 1. I don't have to write the 1 because I already have a number. In this case, I did have to write the 1 because there's nothing else like there. So And then d5 divided by d3, 5 minus 3, which is d to the 5 minus 3 is 2. And notice the c completely cancels out. Okay, I mean, if you can think about it, it's just times 1, but 1 times anything is itself. Now, 36 divided by 4. Now, here, we have to basically reduce it. So let me just do some work here on the side, and I can also show you an easier way to do this in Desmos. But for now, let me show you how to do it by hand. Okay, we're just reducing a fraction. So you have to think of a common number that goes into 36 and 54. There's different numbers, but the first one that comes to my mind is, I think, 9. That's 9 divided by 4 is 36, and 9 divided by, I think 6 is 54. And then 2 goes into 2 goes into 4 2 times, 2 goes into 6 3 times. So this is going to be 2 over 3. If you're like, what, Minsapula? You can always just, use Desmos to simplify fractions. You can do 33 over 54. And if you just press the little fraction button here, it will reduce it down for you, which is 2 over 3. Okay, so that's what I'm going to put here. I'll do 2 over 3. Let me go ahead and draw a bigger fraction. And then here you have 6 minus 3. So 6 minus 3 is 3. So that's m to the third power. And then 5 minus 2 is also 3, n to the third power. Now we can write this as 2 over 3. And then m, we can just write this part like this. Okay, both of them are fine. All right, here is an example of the next rule, which is power of a power. And the rule says that you can just raise the power by multiplying the exponent. So this ends up being x 2 times 8, which is going to be 16. So 2 multiplied by 8. So this ends up being 16. And then here, we can go ahead and distribute. So this is m to the power of 9 multiplied by 4. And then n to the power of 5 multiplied by 4. Okay, so this ends up being m 9 times 4. Let me erase a bunch of stuff here. 9 times 4, which is 36. And then n 5 times 4, which is 20. All right, for this one, now we have to be careful here because it's not just the 7 and 3, but the 5 is also inside of my parentheses. So I have to go ahead and raise that to the power of 3 as well. So let me start by just rewriting everything. So that becomes 5 to the power of 3, and then x to the power of 7 multiplied by 3. Okay, so 5 to the third power, I can either, let me go ahead and simplify. So that's 5 to the power of 3, which is 125, which is the same thing as 5 times 5 times 5, which is 125. I'll go ahead and write 125 here. And then x to the power of 7 times 3, which is 21. Okay. All right, when we see negatives, we have to be even more careful. So you have here negative 3 to the power of 2. Okay, so I'm going to go ahead and keep the parentheses because I want the 2 to capture negative 3, not just the 3 and then the negative gets left out. Okay, you'll see what I'm talking about when I show you in the calculator. But here you have 2 times 2, which is 4. Now, so make sure to put negative 3 and then close parentheses and put the 2 on the outside like that. It's positive 9 because this is doing negative 3 times negative 3, which is negative is a positive, so the negative goes away. Because look, if you don't use parentheses, negative 3 to the power of 2, it doesn't catch the negative, yeah, and then it doesn't calculate it. So this will be the wrong answer. Or if you do something like this, this will also give you the wrong answer. So these two are wrong. These two are correct. Negative 3 squared. Make sure to put it on the parentheses. All right, so this is positive 9. And then you have x to the power of 4, because 2 times 2 is 4. All right. Number 21, 1/2 cubed. So this one is also a bit tricky. In Algebra 1, it gets pretty complicated pretty fast. So these are all the different things that you might see in a problem. Okay, but we'll take it step by step. So you have 1/2 cubed. So you're going to do 1/2. And this whole thing is being cubed. And that matters. I'll show you why in just a second. But let me go ahead and write everything else out. So you have 3 times 3, which is 9. I'll go ahead and write it out all out step by step, because just so you have it in your notes. And then B, 4 times 3. And then C is 5 times 3. And then let's now simplify everything. Now, this is 1 cubed divided by 2 cubed. Okay, so 1 cubed is just 1. And then 2 cubed is 2 times 2 times 2, which is 8. Okay. All right, let me show you in the calculator, because sometimes it helps to just be able to do it in the calculator. So you have 1/2 cubed is that, and you can press this, and that's 1/8. Okay. And then you have A, 3 times 3 is 9. Because it's a power, it's being multiplied, not added. And then B to the power of 12. And then C to the power of 15. Okay. All right. Wow, what's going on here? There's a bunch of different things, but it's okay. We'll take it step by step. Let's do the exponent first with the parentheses. So this ends up being x. So this is going to be 3 to the power of 3. So that's 3 multiplied by 3. And then you have y to the power of 3 times 3 again. And then I'll just bring these down for now and then put everything together in just a little bit. And then this is going to be x to the 9th power. And then y to the 9th power. And then you have x and then y squared. Almost done. And now put the x's together. Now remember, these are being multiplied. So now we can go ahead and add the exponents. So 9 plus 1 is 10. And then y is 9 plus 2 is 11. And that's my final answer. Okay? All right, I'm going to stop this video here. I'll pick up on the next video. All right, thanks, guys.